Hey guys, so we've been learning about ionic compounds for the last few, lessons. There is another type of compound that we've mentioned before that we're going to start learning about here. It's called a covalent compound or a molecular compound. So today in our lesson here today, we're going to talk about what covalent compounds are. We're going to talk a little bit about them, and we're going to learn how to determine whether atoms of two different elements will form ionic bonds or covalent bonds. And that's our target for today, is to be able to determine which type of bond will form between atoms of two different elements. Okay, think back for a minute to the beginning of when we started talking about ionic compounds. We talked about why atoms form bonds with each other and form compounds to begin with. When we had said that they form bonds because they're trying to get the same number of electrons as one of the noble gases. Okay, so you remember we took a look and we said which one is the nearest noble gas and how many electrons do you need to gain or lose to get there. So with ionic compounds, they either gained extra electrons or they lost electrons to become like the noble gas. Well, with covalent compounds, it's the same idea. They're still trying to have the same number of electrons as one of the noble gases, but now instead of gaining or losing, what they're going to do is they're going to share. They'll share electrons. And usually atoms will share, one or two or three electrons to become like a noble gas. So, for example, these elements right next to the noble gases, they only need one more electron. So what they'll do is they'll share one electron with another atom. And that other atom will share one electron with them. And then they'll have the same number. And they'll be happy, right? The next column over, the oxygen group here, the chalcogens, they'll share two electrons because they're two electrons different from the noble gases. The pnictogens, the nitrogen group, will share three electrons because they're three electrons short of the noble gases. The atoms over here on this side, the metals, are many electrons short of the noble gases. So what they will do is they will not form these covalent compounds. They pretty much only form the ionic compounds. So they will not be involved in this covalent bonding that we're going to talk about. Covalent bonds are mostly between these elements that are just a little bit short of the noble gases. So they generally form from the nonmetals rather than the metals. Okay, kind of an important vocabulary word for us to understand as we go forward. It won't be so important for the lesson today, but this is a good time to talk about it, and it will be important for the next lesson after this. If you think about the noble gases and their electron configurations, in their highest energy level, they will have an s orbital and a p orbital that is completely filled, right? In their highest energy level. And so generally, the electrons that an atom has in its highest energy levels, S and P level, we call the valence electrons. So if you think about how many valence electrons could an atom possibly have, well, there could be 2 in the S orbital and 6 in the P orbital, which makes a total of 8. So atoms can generally have 8, what we call valence electrons. The noble gases have 8 valence electrons. The halogens have 7 valence electrons. The chalcogens have 6 valence electrons. And then 5, 4, 3, 2, 1 valence electrons. So instead of talking about the atoms are trying to get the same number of electrons as the noble gases, we could instead say they're trying to get 8 valence electrons. There's one exception to this, and that's hydrogen. Since hydrogen doesn't have a p orbital, it wants to have just that s orbital filled. So it can have 2 valence electrons. We'll talk a little bit more about this in the next lesson where it's going to be important, but it's a good idea right now to keep in mind the term valence electrons, and atoms are looking for 8 of them. Okay, so let's talk a little bit about covalent compounds here. Covalent compounds are also called molecular compounds. So I might say covalent and I might say molecular. They mean the same thing, right? A covalent compound is the same thing as a molecular compound. So whichever term I use, I'm talking about the same thing. Covalent compounds are a little bit different from ionic compounds. Let's say I'm talking about an ionic compound like, let's say, MgCl2, magnesium chloride. Okay, well, if looking at the formula, what that tells me, MgCl2, it tells me that there are twice as many chloride ions as there are magnesium ions. It's twice as many because there's a 2 on it. Okay, that does not mean that there are 2 chloride ions and 1 magnesium ion. It means that there are twice as many chloride ions as magnesium ions. The formula doesn't tell you how many ions they are. It tells you what their ratio is. So what ionic compounds will do is they'll form these big crystal structures with lots and lots of ions. When you look at like a salt crystal, that's all one big crystal structure filled with many different ions. Could be billions or trillions of ions in there. Covalent compounds are different. They don't form big crystal structures like this. They form molecules. Okay, and what a molecule is just a small group of atoms, right? So when I'm talking about a covalent compound, let's say I'm talking about water, H2O, which is a covalent compound. The little numbers in there, the subscripts in there, tell you actually how many atoms are in the molecule. So when I say H2O, that doesn't necessarily mean that in the molecule there's twice as much hydrogen as oxygen. I mean, that's true, but what it's telling you is there are 2 hydrogen atoms and 1 oxygen atom. So that's different from the ionic compounds, where it's telling you the ratio, but not exactly how many there are. Okay, so we mentioned a minute ago that covalent compounds form by sharing electrons, which is different from ionic compounds, which form because they gain or lose electrons and stick together because of their electrical attraction. So covalent compounds, the atoms will share electrons. In each time they share an electron, they will share 2 electrons, 1 from each atom. Hopefully I'll put a graphic right here that'll demonstrate this. So you're never sharing just 1 electron. They always share a pair of electrons, 1 from each of the atom, right? Each shared pair of electrons is called a covalent bond. And oftentimes we will represent a covalent bond, a shared pair of electrons, with a little line between the 2 atoms. So hopefully you can see that in the graphic up there. Sometimes atoms can share more than 2 electrons. They can share more than 1 pair. Sometimes they'll share 2 pairs of electrons. Oxygen is a good example of this, O2. O2 that will share 4 electrons total between them, 2 from each atom. When this happens, when you share 2 pairs of electrons, it's called a double bond. And some atoms can form a triple bond where they share 3 pairs of electrons. Nitrogen is a good example of this. 2 nitrogen atoms, N2, will share 6 electrons between them, 3 pairs, and that's called a triple bond. Now, when atoms share electrons, they don't always share them evenly. Okay, so I have a good graphic for this. Hopefully you'll see that up here. Some atoms pull on electrons more strongly than other atoms. So in the graphic you can see a chlorine atom and a hydrogen atom pulling onto electrons. And chlorine pulls on electrons more strongly than hydrogen. So when they're sharing that pair of electrons, they won't be shared right in between them. They'll be shared a little bit closer to the one that's stronger. And when we talk about the strength, what we're talking about is the electronegativity. And we'll have a chart somewhere where we can look up what's the electronegativity of a particular atom, right? So I can look up the electronegativity of chlorine, and I can look up the electronegativity of hydrogen, and I can see that chlorine has a higher one. So when they share electrons, they won't be shared evenly. They'll be shared closer to the chlorine. When this happens, we call this a polar covalent bond. Polar means it's not the same on both sides. It's different on one side than the other. And so when the electrons are shared unevenly, they're closer to the more electronegative atom, we call it a polar covalent bond. Oppositely, if they do share their electrons evenly, then we call it a non-polar covalent bond, right? So if it's not a polar covalent bond, it's a non-polar covalent bond. And what that means is that the electrons are shared evenly, right? So a covalent bond can be either polar or non-polar. So what we're going to talk about here is we're going to talk about how do you figure out whether two atoms are going to form an ionic compound, a polar covalent compound, or a non-polar covalent compound. And to do that, we need to look at their electronegativities. Okay, so if you want to figure out which type of bond, which type of compound is going to be formed by atoms of two different elements, then what you're going to do is you're going to look up the electronegativity for those two different elements. So what you'll do is you'll go to ptable.com, go over to the side, click on electronegativity, and then it will bring up the electronegativity for each of the different elements. Look up the two that you are interested in, and you are going to subtract them. And when you subtract them, if you get a number that is greater than 1.4, then you have an ionic bond. You have an ionic compound. If you get a number that is 0.5 to 1.4, then you have a polar covalent compound. And if you get a number that is less than 0.5, then you get a non-polar covalent compound. So if you get a big number, they're swapping electrons. If you get a medium-sized number, they're sharing electrons, but they're not sharing evenly. And if you get a small number, they're sharing their electrons pretty evenly. So let's look at a couple examples here. So I have 3 examples here. Let's look at the first one, NO2. This is a compound between N, nitrogen, and O, oxygen. So I'm going to go to ptable.com, and I'm going to look up the electronegativity for nitrogen and oxygen. See, it says nitrogen is 3.04. So I'm going to come over here, and I'm going to write in the middle here, 3.04 for nitrogen, and oxygen is 3.44. So I'll put that over 3.44. And we'll go ahead and subtract those and see what we get. Right, so if you subtract, you get 0.4. And so which category does that fit into? That is less than 0.5. So this compound would be a non-polar covalent compound. Pretty simple. Let's look at the second one. CCl4. This is a compound between C, carbon, and Cl, chlorine. So let me go and look up the electronegativities of each of those. I'm going to look on ptable.com, and chlorine, it says it's 3.16. Carbon, it says is 2.55. So let's go ahead and subtract those numbers. You can use a calculator if you need to. And I get 0.61. Okay. So let's look at where does 0.61 fall. That is between 0.5 and 1.4. So this, CCl4, would be a polar covalent bond. Okay. Finally, let's look at this third example. H2S. So I'm going to go to ptable. I'm going to look up the electronegativity. H, hydrogen, is 2.20. And S, sulfur, is 2.58. Subtract those. And we get 0.38. So ask ourselves, where does that fall? That's less than 0.5, so that would be a non-polar covalent bond there. Okay, so some different examples. Use ptable.com, subtract your numbers. Not too difficult, right? A couple of notes here, a couple of things to say. First, it's not quite as simple as what I'm showing you. If you really want to know which type of compound it is, not only do you have to figure out which type of bond is forming, but you also have to look at the geometry of the molecule, which we're not going to get into at this point. So really, I just want you to be able to predict what type of bond is going to form, just the way that I just showed you. The other note is sometimes people will ask me, sometimes it'll come up, what if you get exactly 0.5? Which one is it? Is it polar or is it nonpolar? Or what if you get exactly 1.4? Which one is it? Is it ionic or is it polar? And what I would say is these particular categories aren't exactly all that clear cut, right? So this is just kind of a word that categorizes how well do they share. There's no clear cut, this is where nonpolar ends and this is where polar begins. If you get exactly 0.5, you might say that it's slightly polar, right? And the difference between ionic and polar, well, if you get exactly 1.4, I would look at that and I would say, is there a metal in there? Because if there's a metal in there, then that's got to be ionic, right? Because metals form ionic compounds. They don't form covalent compounds, right? So if you have a metal, say it's ionic. If you don't have a metal in there, then it'll be polar covalent, right? If it's exactly 0.5, then say it's slightly polar. In terms of getting a question right or wrong, if you get exactly 0.5, say it's polar covalent. If you get exactly 1.4, look and see if there's a metal in it. If there's a metal, it's ionic. If there's not a metal, it's polar. Probably never come up though. Okay, so there's a little bit about covalent compounds and how they're similar and different with ionic compounds. Hopefully that helps us to be able to predict which type of bond is going to form between atoms of two different elements. Next time we'll talk about ways to represent covalent compounds. We'll talk about their formulas, what's called Lewis structures, and how what their names are, things along those lines. So till then.